Hey, this is Mr. Kelly. Welcome to Unit 7, Section 3. We're going to be adding, subtracting, and multiplying polynomials today. That's pretty simple stuff. We're going to get started right with the math. To add polynomials, okay, we just combine the like terms. That's easy enough. So we have to remember what like terms are. We're going to go through and look here. We have 2x to the third power. Remember, we're always looking at the exponent. So we have 2x to the third and 5x to the third. We can add those together. Okay, what else can we combine? Well, we have negative 4x squared, and as we get over to the other polynomial, there's no squared term. There's no term that has a squared on x, so we can't add that to any of these other terms. So we're just going to leave that one. Okay, next we have a regular x to the first power, just an x term. That's the 5x. We're going to combine that with the negative 4x, and then lastly we have just a constant, which is plus 1. So when we add all these together, what are we going to get here? We get 2x to the third plus 5x to the third. That's what? 7x to the third. And then we have to go in descending order. We go down the exponents. We're going to go from the third power down to the second power. There's only that one, negative 4x squared. Then we go to the blue. We have x to the first power is here, so 5x minus 4x, or 5x plus negative 4. That's just a positive 1x, and then we have a plus 1 there. So here's the answer for the first one. Easy enough. Let's look at B. All right, so we have 2t to the third. We have a negative 2t to the third. They're going to cancel out. I then look at the t to the second power. So here's our first t to the second power. Put a little square around it. It's negative 4t to the second power and a positive 4t to the second power. They cancel out. Nothing left there. We go down to the next term, t to the first. Okay, that's all I have here. There's no other terms, so I'm going to bring that down. T to the first. Can you write the first? You can if you want to, but you don't need to. But that's gone now, and we're left with another 1. So this one simplifies to, when you add them together, you combine the like terms, t plus 1. That's as easy as it gets. All right? How about subtraction? Well, if you remember what Sully taught you, this is back in Unit 10 in Algebra. When we subtract polynomials, we're just going to distribute the negative. We're going to add the inverse. Remember subtraction and addition, and when you add the inverse, they're basically equivalent to each other, the same thing. Let's do a quick example. 5 minus 3. We all know that's 2. How about 5 plus negative 3? That's also 2. So it's the same. We're going to use that rule to help us stay organized, because honestly, a lot of students lose the negatives when they're trying to do this in their head, and they just don't know their integer facts well enough. So what we're going to do is we're going to change the minus to a plus, and we change only the second polynomial, only what you're subtracting. Change everything to the opposite. So the minuses become pluses, the pluses become minuses, and then we combine terms just like we did for adding polynomials. So I'm going to start with the highest degree here, the term with the highest degree, 5p to the third. That's going to be our first term I'm going to look at. There's a positive 5p to the 3, a negative 5p to the third. So those terms would cancel out, and then we can go down to p to the second. Okay, so here we have a negative p to the second. So that's going to be negative p to the second. There's no other second term, so that's the only one we have there. We have negative 4p and a positive 4p. They're going to cancel out. And lastly, we have the plus 5. So the answer for C is negative p squared plus 5. Why don't you pause the video and try D by yourself? Go! See how you did here? I wrote the first term, 10y to the fourth. I changed the minus to a plus and changed all the second signs. I then identified by colors which terms are like terms. So then I'm going to go down 10y to the fourth. We're going to go to the third power here. We have a positive 2y, so we write plus 2y to the third. We then go to our second power, so we have minus 4, a negative 4y squared, and another negative 4y squared. That's negative, let me write that, 8y squared. They cancel out. We have plus y and then a minus 1. So that's going to be our answer for D. Easy enough? I mean, we're just combining like terms. You can only add them if their exponents on the variable are the same. That's the key to that there.
No, not that.
Oh, wow.
No broccoli. No broccoli. No broccoli. What is it?
Toothpaste.
What are these?
Deodorant.
What's deodorant?
Keeps your armpits smelling good.
She's gonna get hair.
Are you happy? Do you like your Christmas present?
What? What is it? Well, why'd you throw it on the floor?
It's a Barbie. You broke my heart.
Still, Santa said.
Hey!
Ouch, that's crazy. I mean, here's the question, how would you act? I think that defines what type of kid you are if that happened to you. I like to watch the different reactions there. All right, let's move on. Okay, multiplying polynomials. We call this double distribute, and you've done a lot of this already, checking your factoring. I'm sure that you've been checking by multiplying your polynomials together. We're going to start with E here. Do you have to write in standard form? You really don't, but your answer should be written in standard form. You don't have to rewrite this. But what I'm going to do is I'm going to distribute that 4 all the way across. You have 3 different terms here that the 4 needs to be multiplied on. So we have 4 times 5x to the third. That's going to be 20x to the third. And then 4 times 2x squared. That's going to be a positive 8x squared, and then 4 times negative 7 is minus 28. Okay, be careful with all your different exponents as well. We're then going to distribute that negative x. Okay, it is a negative x because there's a minus in front, so that's going to go to all 3 as well. We should have 6 terms when we're all done. So negative x times 5x to the third. That's going to be negative 5x to the fourth. Okay, the next term, negative x times 2x squared, that's going to be negative 2x to the third. Okay, remember that negative x is like a negative 1x. If you want to put a 1 there, you can. Okay, negative x times negative 7, a negative times a negative is positive, and we're going to get 7x. Okay, so now it's just a matter of combining and rewriting here. So the highest exponent we have is x to the fourth, so we're going to write all of this equals negative 5x to the fourth. That's going to go away. I then go to my third, so we have negative 2x to the third and 20x to the third. So that's going to give us a positive 18x to the third. Next up, there you go away, the squareds, positive 8x squared. That's the only one we have. So we're going to leave that there. Okay, the regular x's here, plus 7x, and then a minus 28. All right, that's easy enough. Let's go on to F here, example F. Okay, for F, what I would do, I would rewrite this as 2 binomials like this. Okay, and remember that if you write it that way, remember this is not, please don't do this. This is something you don't want to do. It's not 2x squared minus 3 squared. That's just not how it works. You can't do that. You have to write it out. You have to double distribute each one of these terms. You got to show a little love here. We get 4x squared. On the outside, we're going to get minus 6x. On the inside, another minus 6x, and then a positive 9. So when I reduce that, we get 4x squared minus 12x plus 9. Well, that's easy enough. How about G? Wow. So G is a little bit tricky because what do we have? 2 steps here. What I'm going to do is double distribute. Let's use this first, and then we'll use the 1. And that x minus 3, he's just going to hang out here for a second. So we're just going to hang on to him, and we're going to say you hold on. But I'm going to multiply the first 2 terms together. When I do that, I get 2x squared. On the outside, I get minus 1x. On the inside, I get positive 2x, and then minus 1. When I simplify, that's what I get first. That's still going to be times x minus 3. When I simplify, I'm going to get 2x squared minus, plus 1x minus 1. All right, that's all times x minus 3. So now we have to play the same game, except I'm going to distribute from the right to the left. I like doing it from the smaller binomial. We get the binomial to the trinomial here. I like going backwards like this. Then I only have to draw 3 of those little arrow things. We're going to get 2x to the third. The middle term, we're going to get x times 1x is plus 1x squared. We have x times negative 1 is minus x. And then we can use that negative 3 times all 3 as well. So negative 3 times 2x squared is negative 6x squared. We're going to get minus 3x. And then positive, be careful, positive 3. Okay, so now it's just a matter of simplifying this. Let's get a little more room here. I'm going to take the terms that have x to the third, so that's 2x to the third. All right, there's nothing left there. Go to the squares. So we have a positive 1 and negative 6. That's minus 5x squared. They go away. We have negative x and negative 3x. That's like negative 1 minus 3, and that's going to give us negative 4x. So they go away, and then positive 3 plus 3. Hey, done with that one. That was easy enough. All right, let's see how you did here. I'm actually going to work it out for you. We're going to do step by step. We have a plus b times a plus b times a plus b. Hopefully you worked all that out nice. I'm going to do the first two here. We'll put it in purple so that everybody can see what's going on. We have a times b. So we're going to get a times a is a squared. A times b is what? ab. Okay. I'm only doing the first two right now. We have a times b again. It's ba, but I'm going to write that as ab again just so things stay consistent. And then b times b, that's b squared. So this is what I get. I get a squared plus two of these ab things, because we have 1ab plus 1ab. That's 2ab plus b squared. That's what I get when I multiply the first two together. All right, so let's put that in parentheses. Let's multiply that by one more a plus b. I know it seems a little tedious here. So what do we get when we do that? All right, I'm going to distribute that a to all three of these terms first. Then I'll do the b. So with the a, I'm going to get a squared times a. That's going to be a to the third. A times 2ab. What's that going to do? That's going to give us 2a squared b. Right? I'm just multiplying by another a, so that a term goes up one. That goes from 1a to 2a's. And then we have a times b squared. That's going to be, I always like to write alphabetical order here, ab squared. All right, so let's distribute the b now. Okay, that's got to go to all three of these things. So let's start. B times a squared. That's another a squared times b. It's b times a squared. I'm going to write it like that. We have 2ab times b. So that's going to be 2ab squared, because we have two b's there. And lastly, we're going to get b to the third. All right, so now I'm going to combine all these things together. So the highest exponent, I'm going to start with the a here. The highest exponent I have is a to the third. And I'm going to look at the a's when I simplify this. So plus, what do we have? There's an a squared b. Here's an a squared b. So we have one of them here and two of them there. That's going to be 3a squared b. Awesome. Then they go away. Now we're looking at ab squared. Well, we got two of them there and one of them here. Remember, there's one in front. So we have 2 plus 1 is 3. ab squared. They go away. And lastly, we have the b to the third. All right, that's as simple as we can make it. Now, why do we go through this whole process? Because we like to find patterns. Patterns will help us simplify our work more quickly and easily if we can find our patterns. Here's some that we already know. The difference of perfect squares. We already know that. Okay, Sully and Bruss talked about this when we have a plus b, a minus b. Remember what happens? It's just the difference of two squares. So if I'm looking at 2x plus 3 and 2x minus 3, I know immediately that that equals, because I know my rules, it's a, the first term, whatever that is, squared, minus b, whatever that term is, squared. And so I can simplify. Don't forget when you have a coefficient in front, that exponent's got to go to that coefficient. But it's going to be 2 squared x squared, or 4x squared minus 9. All right, that's what this one is here. That's one pattern we already have. And because I know that, I don't have to do the double distribute. I just know the rule, and it's faster. Let's look at another one. Square of a binomial. We've done these before. Okay, so here's the rule. I don't know if we've actually looked at the rule before, but here's how it would work. We have 3x plus 1 squared. Let's do that one. It equals a squared, or 3x squared, plus 2ab, plus 2, a is 3x, and b is 1. So I'm going to put a 1 there, plus b squared. So that'd be plus 1 squared. All right, so now I just have to simplify this. Again, that 2 goes to both. Don't forget that. So you get 9x squared plus 6x plus 1. All right, that's fast. Look at how fast that is. I don't have to do double distribute. It's much faster if you can remember these rules. Why don't you try doing this one by yourself? Do the second square of a binomial using the second rule right now. Pause the video. Go. Okay, so we have it here in red. We have 5x minus 2 squared. We have a squared minus 2a. Oh, there's got to be an x there. Forgot my x. Plus 2 squared. So what does that give us? 25x squared. What do we have? Minus, we have 2 times 5 is 10. We get 20x plus 4. Well, that's easy enough. Okay, that made it a little easier for us. So if we know these rules, these are great rules, then we can do our work more quickly. That brings us back to, hey, why did we do that other example? Here's the next rule. A plus b quantity raised to the third power. This is called the cube of a sum. We're going to cube a sum here. Let's go back to what we had. Oh, here we were. Let's look what we have. Here, earlier in the notes, example H, we have a plus b to the third power. Look, we worked it all out before. We got a to the third plus 3a squared b plus 3ab squared plus b to the third. Are you going to have to memorize this? No, I'll give you the rule here. But look what we have now. A to the third plus 3a squared b plus 3ab squared plus b to the third. So this is proof that you actually get these rules. I mean, we worked it out earlier, so we should be good to go. Let's do the first example, then you can do the next example. So let's do x plus 7, and we're going to cube that. We're going to cube that thing. So the rule says we have to do a. Here a equals 1x, and b equals 7. Do we need to write that down? A equals 1x, and then b equals 7. Let's try to figure this out. So it's a to the third power. So we get x to the third power. I'm looking right here. Plus 3a squared b. So plus 3x squared, and then b was 7. Remember, it's the second number. All right. Plus 3ab squared plus 3ab squared. I'm using parentheses so that I square that, plus b to the third power. B to the third power. So it's plus 7 to the third power. So when we're all done with this, we get x to the third plus 21x squared plus 49 times 3. What's that? 147. X plus 7 to the third power, which is 343. So done. How much easier was that? I mean, once we know that rule, we can do this fairly quickly. All right, so pause the video. Try doing the second example all by yourself. Use the second rule. Ready, go. Pause the video. Okay, let's see if you get what I get. We have 2x minus 1. A is equal to 2x. B is 1. So the rule says if we want the cube a difference here, that's what we're doing. We're cubing a difference. What we need to do is, what do we got? A to the third power. So it's 2x raised to the third power minus 3 times 2x squared times b, which is 1. Okay, plus 3 times a, which is 2x, times b squared minus b to the third power. All right, let's try to simplify this. 2 to the third power, be careful, not 6. It's actually 8. 8x to the third. Why? Because it's 2 times 2 times 2. What else do we get? 3 times, well, let's write it all out so we don't make any mistakes. 3 times 4x squared times 1 plus, what do we have? 6x times 1 squared. That's easy enough. 6x minus 1. All right, one more line of simplification here. We get 8x to the third minus 12x squared plus 6x minus 1, and we're done with that. Now, the other way to do it is to do all that distributive property like we did in the first examples. That takes forever, so these rules do actually save you time. I know that you're like, wow, this is dumb. When are we ever going to need this stuff? But when you're programming and you're figuring out code and things like that, you need to be able to simplify these formulas quickly so that your code is more efficient. Let's try a couple right here. Find the product, do A, B, and C. Pause the video. Go! Pause it. Okay, let's talk about this. First, with a, we have a squared minus 4x plus 4. I just do double distributive property, and I get that trinomial right here. For b, I notice it's the difference of perfect squares. Now, I bet half of you probably double distributed again, and that's fine. I mean, if you didn't notice the trick, but you're going to get 9t squared minus 16. All right, last one here. We have a little work to do, so I left it so we could do it together. I notice that this is the cube of a difference here, so I'm going to use the, I got the wrong formula there. Hold on a second. All right, there we go. We have it down here. It's a minus b to the third power, where a is 7x and b is y. All right, let's try to figure this out. Here we go. Okay, last one. C here. We have 7x minus y. That difference is cubed. All right, so I look at my two rules. It's the second one, a minus b cubed. So I've written out a would be 7x and b would be y. All right, that's basically the form that we have here. So we have a cubed minus 3a squared, so it's 7x squared times b, which is y, plus 3ab squared, so 3 times 7x times y squared, and then we subtract y to the third power. So now we just have some figuring out to do here. So 7 to the third power, x to the third power. I think that's 343 if I'm not mistaken. So 343 x to the third power. What do we get? 7 we have to square first. So it's 3 times 7 squared, which is 49. I believe that's 147. X squared with a y. Next we get 3 times 7, which is 21x x with a y squared minus y to the third power. These are all different here, so we can't put them together, but look, we're done. That rule made it so fast for us, because if we didn't do that, we'd have this huge mess to deal with several different terms. We'd have to combine like terms, and I guess if you want to, you can always do that. But hey, this is slick and easy, and I'm going to give you the formula, so that's like a piece of cake. So, this is Mr. Kelly Baumholder. That's it for 7.3. You're going to be halfway done after you get this done. Remember, it's nice to be important. It's more important to be nice. Soup!
Soup.
Yeah, I know how much you like soup.
No. No. What is this?
It's a sponge.
I want a car.
A car? Yeah. Maybe on Christmas Day Santa will bring you a car.
Oh, what's the matter? Don't you like broccoli?
It is so funny.
What is it?
Really, taco seasoning.
Yeah, don't you like tacos?
I'm only 6, I can't make it.
Yeah, you can.
Ugh.
Hold it open so I can see it. Hold it up. Oh, it's a 3DS. And
You got a 3DS.
a Mr. Potato Head. That's what you wanted for Christmas.
No, a 3DS game. This is the food that we get used up today. It's so fair that you give us no more. I'm going to just throw this away.
That's what you wanted, Sean.
You gave me the boringest stuff, and you guys are such the worst. I hate it.
Jack likes his present.